Hello, let's solve a new question today. Valid Sudoku. Determine if a 9 cross 9 Sudoku board is valid. Only the filled cells need to be validated according to following rules. Each row must contain the digit 1 to 9 without repetition. Each column must contain the digit 1 to 9 and each of the 9 3 cross 3 sub boxes of the grid must contain 1 cross 9 contains the digit 1 to 9 without repetition. Note, a Sudoku board partially filled could be valid but is not necessarily solvable. Only the filled cells need to be validated according to the mentioned rules. Example, okay, this is a normal Sudoku board, Sudoku, whatever it is called. 3 3 3. Okay, so 9 rows and 9 columns are there, and then there are sectors of 3 cross 3 smaller cells, and we have to just check for any row we have distinct one numbers between 1 to 9 and there should be no duplicates. Yeah, okay, and so is the case with columns and cells. So this is the board. Okay, so input is a character 2D array, sure, row and column, and then output is boolean, whether it is a valid Sudoku or not. Another example, fine, constraint board length is 9, so it'll always be a 9 cross 9 matrix. Board ij is a digit 1 up till 9 or dot, so empty cell will have dots, dot, and otherwise will have digits in the cell. Sure, let's understand the problem first. Let me clear this up. So we have a 9 cross 9 board. The rule says each row must contain the one digit 1 to 9 without repetition. Each column, same rule. So if we look at, let's say, a random row, this one, so all of the numbers should lie between 1 to 9 and there should be no repetition. And let's say this column, same logic, that's easy stuff as well. Each of the 9 3 and then sub boxes will have different 3 cross 3 sectors. Yeah, we have to check whether the things are distinct in there as well. So looks like, at first glance it looks like pretty straightforward question if we do not think too much about, okay, how can we optimize it, how to reduce the size of the code or anything. The first thing that comes to my mind is we have just 9 cross 9 grid, right? 81 cells will be there. So what we can do is, in this grid, okay, you just iterate through all the rows first and check if all the distinct non-repeating numbers between 1 to 9 is there. Then we do the same thing to all the columns, and then we do the same thing to all the 3 cross 3 sectors. What will be the time complexity of this? So we are iterating, in this case we are iterating through all the rows. So, and at every row we have to go through all the numbers, so all the columns at that row, we can maybe keep it in hash set just to check if there's a duplicate. So this is going to be linear forever. So okay, for row checks we have to go through all rows and at every row all columns. So that is n cross m for row, sorry, what happened, okay, n cross m for row validation. We have to do the same thing again for column validation. Can we merge it? We'll think about that later. And at the end, for sector validation, technically we can just start from here. So we can think of sector as just normal matrix. As so this is the first cell of this matrix, and every cell will have, let's say, 9 items, right? So we can just do normal matrix iteration, this and then this, right? So how many sectors will be there? 9, and in every sector will have 9 cells, right? So again n cross m for sector validation. So overall it is going to be, the overall time complexity would be 1, 2 and 3, just adding all the 3 items. So 3 times n cross m. N and m, okay, n cross m. What is size is 9, right? 9 times 9 is 81. So it it works fine, looks good, it will work. Okay, so we know that with this approach we can just find out the solution quite easily. I'm just thinking, am I missing anything? Row validation, column validation, sector validation, sure. let's create let's write some pseudocode maybe. Yeah, that probably will give us more insight and better understanding. Sure. So for row validation, we will have to iterate through the rows, and at every row we have to create a hash set. So it will look like I is equal to 0, I is less than or row max, max I plus plus, right? Normal for loop, and within every row we create a hash set, okay, and then there's going to be a validation, sure, and that is the end of row validation. Then we would have to do column validation, right? Can we, okay, instead of creating hash set again and again, probably what we can do is, this is the hash set, can we use the same hash set here? You know what, instead of using hash set, because the size is always going to be 9, right, it'll be a good idea to just use a boolean array, right? So think of it as 0 up till 8 are the indexes, and at every index we have true or false. By default everything is false. Whenever, let's say, we are iterating through first row and the numbers are 1 2 3 and then 1 and few dots, and at the end 9. So what we can do is, this is our boolean array 0 1 2 up till 8. So we encountered 1, we'll set at the first 1 till 9, 0 to 8 we have to map it, right? So 1 will map to this one, right? So we have found 1, 2, so 2 minus 1 we have found 2, 3, 3 minus 1 we have found 3, 1, because 1 minus 1 is 0, it is already there, so we have found that number. We have already visited that number in this array, so we are going to just say that okay, there is duplicate and it is invalid, right? So all I'm saying is we have numbers from 1 to 9. We can keep the array, create a boolean array with 0 to 8 index, the size of 9, and we can map things in this. And yeah, every time we move to the next next array, so next row, we would have to clean this up. Let's think about that. Will that be a overhead? One option is to just create a new boolean array. Second option is to clean this up. If we clean the existing array, the boolean array of size 9, because it is linear, okay, and we have fixed size, we can essentially think of it as, although it is technically big of n, but n is always 9, so it is, we can consider that as a constant time complexity. So overall, cleaning this array up should be cool, should be okay. So we move to the next one and we keep on doing this across the rows, and then we do this across the columns. Let's talk about sectors then. How we would have to do some kind of index mapping for sectors. We'll talk about sectors when we get to sectors. First, let's solve row validation, column validation. These two are pretty straightforward. Then we'll go to sector validation. Let's write some code. Okay, so we are going to do our row validation first. What that would mean is, first we should know the row size, the number of different rows that we have, not row size, row max. That is just board dot length. Yep, sure. So let's iterate through all the rows. We are in the row now. Now we have to iterate through all the columns, and better to keep a boolean variable visited, new boolean. It will always be of size 9. Better to make it more dynamic, so column max and board 0 dot, and we'll add a validation that at least one row needs to be there, otherwise it is going to throw exception saying that there is no index and still you are picking board 0 if the board is completely empty. So we'll do call max, then we iterate through the column, right? Sure. And we are going to say, that is okay as well. Yeah, we are going to say visited index, the number that we have visited. So the number is going to be, it is in character, of type character, we'll say. So number visited is board row column. This is a character array. We have to convert it into an integer. Okay, 5 is 5, 3 and 3 is 3. Let's cast it into an integer. So this is a number now. Now we'll do number visited -1 plus plus. Now the only problem would be when we have a dot in that cell, because it is going to throw an exception while casting. So we'll check if board ij is empty, then we have to ignore it. So when this is not the case, that is only when we would like to do this. Cool. Okay. Not visited. We are saying we have visited this number. Before setting it up, we can just check if same thing. If it is already true, that means we've already visited that number in this row, and so this will be an invalid Sudoku. So if visited already there, we return false. So we just return saying that okay, this is an invalid Sudoku. We do not have to process any further. Otherwise, we do this. Sure. Column for I is equal to 0 board number visited. Okay. Column fine. So that was logic for row validation, and if our execution has reached to this point out of for loop, so we never got to line number 20, that is this condition was never satisfied, and so we can safely say that row validation was successful. So we've if execution is at this point line number 26, so all of the rows are proper, there's no problem in there. Let's just double check if everything is fine. Are we sure that if a cell does not have a dot, it will always have a number between 1 to 9? Let's check that. Otherwise, we would have to. It says board dot length is 9, board is 9, board ij is a digit 1 to 9 or dot. Okay. So in constraint, it has already been mentioned that number, if the cell does not have a dot, it is going to have a number between 1 to 9. Cool. So we do not have to do any checks for that. Let's go to column validation now. It is just a copy of row validation, and because we are kind of repeating the code, we are going to create another function and just call the function 2 times and reduce the code. We'll do that later. Row validation. Now we'll enter in column validation. The code stays as it is with minor changes. So row max, column max, we already know. Now in this case, we are going to iterate through the columns, and we are going to iterate through the columns, and at every column we have to iterate through the rows. Yep. So I represents column and J represents rows. Sure. Visited number visited -1, return false, otherwise set it to true. And we are done with column validation as well, right? Sure. Let's get to the final piece. In the three conditions, we have already solved the first one, we have gone through the second one, we are left with the final one. 3 cross 3 sub boxes of the grid. It must contain a number between 1 to 9. Sure. Now the thing is, let's talk about it. How do we iterate through it in a simple way? We do not have to overcomplicate things. We start from, we think of this complete cell as 0, 1, 2. So this, think of, ignore sub boxes, just focus on these boundaries. The first one, second one, third one, and fourth one. In this way, we know that it is a 3 cross 3 matrix, right? What we do is we just do iterate through that 3 cross 3 matrix, and once we are in a specific matrix, then we have to iterate through from the starting point these cells. Okay, this is going to be a good interesting iteration. So let's try to create maybe a formula or something. We'll see. Sorry. So we are left with the final piece, and that is sector or sub box validation. All the sub boxes should have distinct numbers 1 to 9. There should be no duplicates. How do we do this? Let's see. To pick black color. So no need to generalize it. For now we are just going to focus on 9 cross 9. And as I was saying, let's just think of this as a large 3 cross 3 box, and every box has then this cell. So this is 0 cross 0, the first cell. This is row is 0, column is 1, row is 0, column is 2, row is 1, column is 0, up to so on, and this one is going to be row is 2 and column is 2. Now if we can find the first cell of all of these matrices or sub boxes, I think we are good to go. How do we do this? Let's understand. So this is plain and simple, actually 0 cross 0. This is going to be 0 1, 0 2. This will be 0 3. 0, row stays same, column is 3, 4 5, 3, 4 5 6. This one is 0 cross 6. So in these cells, this is magnitude, maybe 3 multiplied by something. So this is 3 times 1, this is 3 times 2. So maybe it has to do with 3 times the sub box number. Okay, but what about this? This is row is 1 and column is 0, and this was fine. What about this one? Row is not 1, sorry, is 0 1 2 3. Row is 3 and column is 0, and that's why this needs to be this. And this one is row is 3 and column is 1 2 3. Okay, so what we can do is, and what is, if we just consider the larger matrix, it was 1 comma 0, right? So what we can say is, in this case again, times 3. Okay, and this one is, this one in larger matrix, this one sub box system, it was 1 cross 1. So is it just me, or it is basically the first cell in all of these cases, the first cell in all of these cases is 3 times whatever is the row and 3 times whatever is the column in larger matrix. That means, as I said, this in larger matrix is 0 0, this is 0 1, this is 0 2. So 0 0 0 cross 3 is 0, 0 cross 3 is 0, so it actually is 0 0. This is 0 1, 0 cross 3 is 0, and 1 cross 3 is 3, so its actual position is 0 comma 3. For this one, this matrix is 0 comma 2, and the position of this cell is going to be, just multiply both the side by 3, so 0 comma 6. And if we grab, let's say, anyone, this one, 0 1 2 and 0 1 2, row is 2 and column is 0 in the sub box matrix, this one, right, in this one, and actual position is going to be times 3 times 3, that is 6 comma 0. 0 1 2 3 4 5 6. Sure, so we have got a good number, so we know the starting point, and all we have to do is, from the starting point, we have to slide to the left by 3 units, down by 3 units, right? So in this small matrix we have to do 3 cross 3 iteration, right? So sure, we just have to iterate through the row and column. So every submatrix then can be considered as matrix. We do a normal for loop where we execute this, then go down, this, go down, this, give it in hash set. Okay, let's try to solve this. So what I was saying is, let's understand this. So the third piece is our sector validation. We know the row max and we know the column max. Row max divided by 3 and column max divided by 3 will be the size of the row and column sectors. Yeah, so row max, let me just move it up a little. Row max in sector form is row max divided by 3, and column max in sector form is column max divided by 3. So think of this as we are just creating another world where this actual matrix gets converted into the 3 cross 3 with the bigger chunks, where we just have to ignore all the smaller cells. We just focus on, or we just think of all the 3 cross 3 cells as one cell of the matrix, right? So our new row max, number of row maximum, is going to be whatever the actual max was divided by 3. Actual was 9, 9 divided by 3 is 3. We have 0, 1 and 2. 0, 1 and 2, total size is 3, and so is the case with column. Okay, now we have to iterate through this matrix normally. So we do row max sector plus plus iterate through columns. So now when we are here, we are iterating through these sectors one by one, right? Now we are in the sector. Now we have to grab this one. We have to create a matrix from all the sectors. So we find out all the starting points. So int start matrix index is going to be okay, start, let's keep it simple and tiny. Start row is 3 times the current I, and column, start column is going to be 3 times the current j. So we got to that point. Now we have to do a normal 3 cross 3 iteration in this. So we do, but let's keep it dynamic. Okay, so we have to actually, to make it dynamic, we'll do sector size and we'll keep it 3, right? Sector size. So int row is equal to start of the row. Row cannot go beyond row max. Just think about it. Start of the row, it should not go beyond a specific size, and that would be, we know that this is the size of the rows. This represents a different thing. This is row max sector. This is going to be sector size. So we'll say start row plus size of the sector and row plus plus. Let's double check this. So if we are at 3 comma 0, right, this one, this cell 3 comma 0, we can go to 3 comma 0 and then 4 comma 0 and 5 comma 0, but not 6 comma 0. So we are saying 3 plus 3 is 6, so we do not want to get to this point, right? So that is iteration for the row, and then we are going to do column iteration. Start column, column is less than start column plus sector size and column plus plus. Now as we iterate through it, we can keep a visited array. Let's just write it boolean visited new boolean, and the size will always be 9. We'll think about making it dynamic later. Visited is 9. Then we just find the current visited number. We just have to repeat this. If the board, we'll think about ij, we'll change that. Okay, so the row represents actual row and column actual column. Row, column, number visited, visited, number visited, return false, sure, sure. Okay. For I is equal to 0, I is less than row max sector I plus plus less than column max sector j plus plus. Looks good. And if we have reached to the end, that means there was no sector validation. And there was no problem any of the sector. The validation is successful. Let's just double check this once, iterating through this at every large subsection. We're starting the row, starting the column, iterating through the row and the column. Okay, and we are keeping a track of board row column number of visited. This visited for every sector is refreshed because we are creating a new instance, and so is the case with column visit. Column validation, yeah, for every column we are refreshing it, for every row we are refreshing it. Looks good. Let's check this. What's this? Runtime error. Index was outside the bound. Interesting. So we have this board and it is saying, okay, most probably, see, index out of bound issue j ij number visited -1. It can happen either, maybe if we get any number not in one to, maybe we'll say column row, j represents row, I represents column. Okay, and at the end we have the sector validation. Maybe the issue is with the sector validation. We'll check this one by one. So for now, let me just remove the sector validation to be sure that it is happening because of sector validation. Okay, it is not. It is happening because of this visited array. Okay, let's get it back. Board length column, and let's check what do we get in number visited. Let's see. Output is 53. So the problem has to do with this one, parsing a character into an integer. Hmm, interesting. What did I do wrong? Let's think. Let's see. Uh, String character number into integer C sharp. If it is 2, just subtract it by 0. So we'll convert it to an int. Are we saying this will solve this problem? Basically, the because we have this number printed just once, that means it just got to this point. We got the parse result output as 53 for a character number between 1 to 9, and yeah, it tried to fill that index and it threw the exception. So let's see, now we should get few more numbers, and then in the second iteration it'll throw exception, just to be sure. That is what is causing the problem. Index was out. Interesting. Sorry, console write line. Yeah, that did solve the problem. So what we have to do is we have to wrap this to convert character number into integer number. Then we have to do that here as well. Okay, run this. Okay, so our two test cases have passed, and we are sure that board length is going to be 9 cross 9, right? So we do not have to do validation on this one, board 0. We do not have to add a check here that board size needs to be, if board size is 0, then just return out of it. Let's submit this and see if this worked. Okay, it did work. The memory used is quite good. Runtime is fine as well. So we have solved our valid Sudoku problem. We just did a row validation, a column validation, and a sector validation, and yeah, it worked well. Thank you.